Let's continue system design. Today, I am going to discuss one of the key basic concepts of system design is consistency. So, in distributed environment, let's you are uh, added multiple nodes or multiple servers, and you are storing data storage here, data storage here, data storage here. Okay, maybe replicated in the different places. So sometimes the major challenges with respect to the data. So might be multi-masters. Means this data accessed by at a time. This is also accessed by. This is also accessed by. For distributed networks, different data are accessed by the different times. So the system design responsibility is that ensure that data should be consistent. Let's see here data user profiles particular details here. The same user tile profile must be here and must be here. Okay, so if let's say this node, this server are going to update his data from here. Okay, so at the same time, if let's this person is trying to access try to access the same data, so consistency refer that whatever the changes here instantly is applicable here is replicated here, so that all the reads on any nodes ensure that updated value are read by every node. It is not a case that here I updated and here multiple times I try to read, still I am getting the old value or not the updated value. This is the scenario consistency problem. Means sometime user profile view some data and sometimes different data. This is the data consistency problem. So whenever you are designing such distributed system where your data are replicated in the different node and different nodes are simultaneously allow read and write operation. So in this case, as our responsibility, we have to ensure that some level of data consistency must be maintained. So this is the one of the also key concept while the system designing. You also focus how I am ensuring that our data is consistent. Consistent means same data, updated data every time will available on the every node. Okay, so let's talk some details about this consistency. Consistency is guarantee or ensure that or give the reliability to the customer. Hey, all the nodes here, nodes means all the servers where your data are stored, basically in distributed systems, agreed on a single value or state, even the presence of failure or concurrency. So here something maybe failure happen or concurrency means the same time multiple requests are tried to read the same data. So whatever the value or state means current updated value. So this value must be available, must be guaranteed, right? So in what the it is also ensure that the system behavior is predictable and accurate. Accurate means whatever, if this instance are changing some value, this reflected value will be available for the all the node, even dealing with a multiple user request are the nodes. So here concurrent means concurrency means the multiple users same time and the different nodes, different server fetching your data. If some thing going to change on the backend or some requests modified, so our responsibility, we have to ensure that all the latest value, updated value everywhere across the distributed systems from where the users are going to read, that must be available. So consistency is also very key concept in the case of data. Customer reliability. If you are not displaying or not rendering, not responding correct value, here knows the accuracy. So consistency ensure your accuracy, means customer reliability, less defect if you are ensuring this consistency. Data consistency, basically I am talking, whatever the value, whatever the data you are storing in the distributed system, those data are read or write by the multiple user, concurrent user, same time multiple user. So you have to ensure that updated latest copy of the value will be available for each and every request. So generally these are the some approach or techniques to ensuring that how we can implement this consistency while designing the systems. So first, our most basic mechanism about the locking. Whenever a particular transaction going on, use the locking to synchronize the access to the shared resources. Means any resources you want that multiple peoples are going to read, you have to ensure some kind of lock management. If something modified happen, the record is locked and updated to every places, and after that you are going to ensure that hey, now available for read everyone. So locking is the one of the simple and simplest way. If you talk the database level, transaction level, locking mechanisms can be on the different layer. But locking mechanism is lock means just like a simple lock. Lock means just provide the one. This is the shared resources, and if there is no lock, that means this access by any number of user. And what happen if I am going to modify something at that time? I want to ensure that I modification at this time, every request must be wait until I am not updated. If updated, after that everyone can get the data updated value. So this is the locking mechanism, or sometimes say synchronizations between the users, between the set. So whatever the shared object or the particular data, a particular value that's are accessible by the lots of user, so you have to apply the synchronization capabilities. And similarly, second level of transactions, whatever the transaction is multiple operations you are doing, ensure that those transactions are ensuring that the multiple operations are executed on a single all or nothing kind of atomicities we have discussed in the while the database access property. So these all the set of operations or query are executed all or none. If something update happen, everything happen or nothing happen. So that means our data is consistent. And sometimes we have to also use some specific consensus protocols. This protocol maybe you can POX OS or Raft or the two-phase commit to agree on the single value or state. So these are the some different protocol. Two-phase commit that's a Google use, Raft use. They are ensuring that if only single copies are and that our updated copy is available for everywhere. We are not saying hey, some node have an old copy, some node have a new copy, some node have an old copy. No, this is not. If something available everywhere or none. So this is the some consensus protocol you can apply to ensure to offer in your system as a consistency. And one of the also simplest way, use the replica, that means maintaining multiple copy of data to ensure the availability and consistency. So whatever the data you are replicating different in distributed networks, you are also ensure the same data you are replicating the all the nodes, so that you are maintain one level of consistency. So the lots of techniques approach available to ensure your data consistency, but these can be also basic synchronizations, or you can say transaction, atomic locking, ACID property, These are the consensus protocols, data replications, the following technique which help ensure that whatever the system you're designing, that is some level of ensure that your data is consistent. So generally, if you talk types of consistency, so you can say lots of, if you look the Google and find out consistency, dozens of types of consistency you can find. But I'm not going to talk all those things. I have preferred to talk these 2 points. Maybe strong consistency or weak consistency. Weak consistency, that means we're going to talk if the distributed networks some delay, some latency to, let's see here, data going to update, microsecond and millisecond will take to reflect data in the other node. That is known as sometime eventual consistency. Data will be consistent but might be some delay. That is known as a weak consistency. And somewhere the strong consistency, there is a no delay if everything updated here, same time updated on the all the node, all the places. So overall you can say strong consistency or maybe compromise, maybe weak level of consistency. We can discuss these as well. So lots of kind of consistency. I'm not going to discuss it, but at least you have to aware these 2, strong or weak consistency. So let's see strong. So where you can say strong consistency, also known as linearizability. So here, what the kind of requirement where you are going to ensure that strong consistency must be implemented. So generally, a strong consistency system are suitable for high stakes, real time application where accuracy is very critical. So like your finance domain, banking domains, where we are not avoid any kind of data incorrect. Accuracy is very critical for me. So that way, whenever you are going to implement this strong consistency, that's very expensive to implement such a strong consistency. Whenever you put the strong consistency, at that time sometime we can increase your latency. Your latency is going to increase. So this is the, you can say, some kind of a trade-off. Whenever you are ensuring very strong consistency, at that time you lose your latency. Latency is your response time. If I use a request and what the response, how much time it will take. So might be, if we are going to implement strong consistency, we have to increase our latency in the system. We have to compromise something. If we talk the basic concept here behind the strong consistency, ensure all the node in the systems agree on the single value, and that's agreement maintain instantaneously. That means ki all the operations, whatever the update, add, delete operations going to occur, instantaneously applicable to most recent value to each and every node. So like in the banking systems, all the nodes must agree to current account balance. Whatever the place you are accessing my current balance or debit, whatever the system, financial system, always data must be required consistencies. All the like financial transactions are critical real-time systems where you need very strong consistency. So we can maintain strong consistency, but we have to avoid some kind of latency. Our latency is going to increase. So let's talk about the similarly weak consistency. Yeah, you can say eventual consistency. That means the data is consistent, but there is some lag sometimes, because the weak consistency are suitable for the social media platform, caching layer, CDN networks, where the consistency is not so critical. So here they may have a higher latency but inconsistent a consistency may occur. That means here we may reduce our latency, but we are offering some level of you can say delay syncing data between the multiple nodes, right? So here you can say all the nodes temporarily disagree on the value or state, but ensure that eventually all the node will the same value. Means let's say we have 10 nodes in the system, and someone going to do some update operation, delete operation here. So these operations must be going to reflected the this node, but it will take little bit times, nanosecond and millisecond sign. After that it will become a consistent. Due to that, say, hey, this is the eventual consistency. Here means I want our system more performance, more highly responsive. Might be some delay data after some time will able to ensure. Here say data will be consistent, but it will take some time. Okay, so temporarily maybe possible in this such system, temporarily the value you some minute of times is not you can say updated one or real time, but after some time it will get the most recent value. So like social media platform user post may take some time to propagate all the nodes. Let's say you write one message, and this message is distributed to the dozens of nodes, might will take some delay. So this is no harms, there is no any kind of loss. If I writing the message take 1 millisecond, 2 millisecond to reach my all the follower, it's not problem. So where such a social media platform, caching layer, yeah, CDN, where little bit delay is manageable, that is known as your data will be consistent, but some lag, some late. So similarly, if you talk this kind of consistency always needed in the different. If you talk about the Google Cloud Spanner, they are use this protocol, consensus protocol, to ensure strong consistency. Like similarly, if you talk the Amazon Aurora, they use the quorum based protocol to achieve the strong consistency. Even if you talk about the Apache Cassandra, they use the gossip protocol to achieve the weak consistency, that means eventual consistency. If you use the Cassandra database, they can say they are support the eventual consistency. That means your data is going to replicated all the node, but it will take some microseconds, some milliseconds time, but there is the guarantee data will going to consistent, but it will take some time. Similarly, you go to the Amazon DynamoDB, it's also use the like vector clock algorithm to achieve the kind of again eventual consistency. Microsoft SQL Server is strong consistency also ensure in the locking mechanism. Similarly, Oracle database also use the locking mechanism to ensure the strong consistency. So lots of data storage services, cloud, non-cloud, you have to think what kind of a way we can achieve strong consistency or eventual consistency. So these are the basic kind of points. So whenever you design systems and your data is distributed in the multiple places, and multiple nodes are reading your data, you have to ensure that if the original data are one place, any nodes, some value going to modified, so quickly replicated, place the original value to every node. Even on one node, if the concurrent user going on, if something one user going to do modifications, the updated value, the latest value must be read by every concurrent user or multiple users at the same time. This is possible through your consistency. The consistency has a two level. One can be strong consistency, one is the eventual consistency. So whenever you implement strong consistency in generally all the critical missions applications like your banking system, financial system, mission critical any applications where you want data should be updated and accurate and correctness. Every moment, each moment data should be always correct. Whatever the data displaying should be always updated the latest value. So you go the strong consistency. While you implementing strong consistency, you have to lose your data availability, or you can say latency is going to increase. Okay, but you are going to increase other application, maybe social media, blogging, video gaming, everywhere might be data required consistency, but it will take, can be manageable. Can you compromise little bit slowness? In those scenarios, you can do eventual consistency. Data will be consistent, but it will take some time. So you can say eventual consistency. So whenever generally depend upon the nature of our customer requirement, sometime you can go with the strong consistency, sometime you go with the eventual consistency. Eventual consistency have a very latency is very you can say high, you can say means very quick response, highly available system. But in the case of your strong consistency, might be you can lose some kind of your high availability kind of things. You cannot available instantly every node. So you have to maybe some kind of, due to the locking mechanism, synchronization mechanism, some you can have a latency your application going to increase. So please keep in mind while designing systems, your data consistency must be depend upon the use case, depend upon the applications which are building. You have to decide we are go to the eventual consistency or strong consistency. Hope this information helpful for you. Thank you.